Hello everyone, I'm Dankun Zhou, coming from Nanjing University in China. I'm very glad to have this opportunity to make a presentation here. I have had 2 months secondments from 27 October to 31 December in 2017 at the University of Strathclyde, and my supervisor there, a Professor Alessandro Tarantino and Dr. Elsa Joy. Thanks for their kind help and patient guidance. I have benefited a lot from the visiting time. Thanks for the sponsorship from the great project, so I can fulfill this visiting research. Okay, let's come back to the topic. My research topic is evaluation of urban underground space resources for sustainable urban development. Here, we look urban underground space as resources can be used for urban development. My presentation includes three parts. First, I will give an introduction to my topic. Then, I will show the methods how to conduct the evaluation process. Finally, a case study in Nantong City is given. Why do we pay attention to the underground space? Development of urban underground space is a growing imperative. It can solve the city syndrome and is an important guarantee for sustainable urban development. China is in the stage of urbanization. Urban development needs more space, but we also have an arable land protection limit. How to increase the space without occupying more land? The underground space is a good choice. It can improve the city capacity and promote the intensive use of land. Subway and underground parking can solve traffic congestion obviously. Underground space can also enhance urban disaster prevention capacity, for it has a nature to resistance to earthquakes and not disturbed by the ground. In addition, use of underground space can improve air quality and urban ecology. Look at the pictures in the lower right corner. It is a comparison between before and after bringing the wastewater treatment plant underground. It is also said that the 21st century is a century when mankind develop underground space. No matter from the view of the needs of urban development or its own advantages, we need to develop the underground space. However, subject to the geological environment, economic strength, and technical level, the underground space can be used for urban development is limited. Once underground facilities are built, it will change the original geological environment, and not like ground facilities. It is difficult to remodel and dismantle. Once a adverse geologic environment effect is formed, it is extremely harmful. Also, the development of underground space resources is hit races, hampered by first come, first served. Look at the picture about the Wall Street in the early 20th century. The underground space is a total mess. So make full use of this precious and limited resource. We need to make a rational plan and plan ahead. Helsinki, Netherlands is a good example of underground space planning. Based on geological survey and city demands, the city planning department have made the underground master plan, and the plan was approved by the city council. Currently, The underground space development model in China is top to down, mainly driven by local demand, not bottom to up, means that taking into account the properties of the resource itself, like different soils suitable for growing different plants, different regions have different attributes of underground space. For a rational development plan, survey-based evaluation is necessary. The objective of my research is to establish a set of evaluation methods based on the identification of properties of urban underground space, serving for the underground development plan. Next, I'll give a brief introduction about the method for underground space resource evaluation and a case study in Nantong, China. Identify the properties of underground space resource is the first step to evaluate. We think the attributions of urban underground space depend on three aspects: urban location, ground conditions, and geological environment. The first two aspects belong to the man-made environment. They include socio-economic conditions and constraints from man-made facilities. Socio-economic factors include population density, benchmark land price, land type, and so on. Factors about constraints from man-made facilities include existing ground and underground facilities, ecological protection requirements, cultural relics protection requirements, and so on. Geological environment belongs to the natural environment. It includes factors such as tectonic stability, hydrogeological conditions, bedrock and soil, and so on. We think socio-economic conditions determine the potential development value of underground space. Constraints from man-made facilities and geological environment together determine the development difficulty of urban underground space. The comprehensive quality of underground space depends on the potential development value and the development difficulty. Use AHP with ArcGIS software to implement the entire evaluation process. Through the set investigation and data collection, we know about the development status of underground space. Existing underground facilities marked in the map. We can also find some problems in developing the status quo through this process. Based on the collected borehole data, the three-dimensional geological model is built. This helps us to better understand the geological structure of the city. This is the evaluation result. Three-dimensional geological model help us know about the geological structure of the city more clearly. Based on the influence of various socio-economic factors on the development of underground space, the potential value hierarchy map of underground space development is obtained. Similarly, based on the influence of various existing facilities, environmental protection requirements, and geological factors on the development of underground space, the development difficulty hierarchy map is obtained. Here the development potential, the less the development difficulty, the higher the comprehensive quality is. According to this principle, we can get underground resource of different comprehensive quality within the urban area, and this can help us make a more rational urban underground space planning. Through analysis of the impact of various geo-environmental factors on the development of underground space, the grading map of influence degree of each factor is obtained. Through the analysis of impact of various socio-economic factors on the development of underground space, the grading map of influence degree of each factor, such as population density, land type, transportation condition, benchmark land price, and so on, is obtained. The same way, the map of influencing factors of existing facilities and environmental protection requirements is obtained. Based on the established mathematical evaluation models of potential value, development difficulty, and comprehensive quality, divide the study area into many small evaluation units with ArcGIS customized toolbox functions to achieve assessment. That's all. Thanks for your attention. If you are interested in my research and have questions want to ask me, please contact me with the on-screen email. Bye bye.